4. Yeah, Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, our esteemed students. Let us begin with our first lesson for this week, chemistry continuation on the properties of chlorine. Before we look at today's lesson, ours is to review briefly what we covered the other day. The other day we covered that generally chlorine reacts with metals. So the information is metals generally burn in chlorine to form white fumes of respective metal chlorides. That is what we covered, and that is what we concluded on. So what we see as white fumes are very small particles, solid particles that are suspended in what? In air. The way you see what? Dust. The way you see dust. Dust is soil particles suspended in air. Given some little time, what happens to the dust? The dust what? Settles. And you can see it as a brown solid from soil. So the white fumes is not a gas. They are solid particles. And therefore, from the name of the metal, you can get the name of the chloride. So what do you expect? Sodium will give you sodium what? Chloride. Potassium will give you potassium chloride. Magnesium will give you magnesium chloride. Copper will give you copper 2 chloride. Why copper 2 chloride? We have two types of copper. Copper 1 and copper 2. So with the chlorine, you get the highest is the one that you get. So what do you expect if copper gives copper 2 chloride? What about iron? There are two types of what? Iron. Iron 2 and iron 3. We get the highest iron. So which iron do we get? Iron 3 instead of iron 2. And you finish all of them. So even if we call these metals different names and so on, that's not the major issue. As long as you know the name of the metal, you form a metal what? Chloride. You know the balance of the metal, you write the what? The equation. So if I pick on magnesium, magnesium has a valence of 2 and it is a solid, plus chlorine, which is a gas. So what do we obtain? Magnesium chloride, which is a solid. But as it is forming, it's seen as white what? Fumes that will now settle to give you a white solid. So if it is copper plus chlorine, what do you expect? Copper 2 chloride. If it is iron solid, what do you expect? We said the highest form of iron is iron what? 3. Because chlorine is a very powerful oxidizing agent. So to balance our equation, we talked about odd versus even. Here this is odd, this is even. So to make it even, what do? We put a number that will give us an even number. And I think if 1 has not helped us, when you try a 2 here, this one's become how many? 6. And this is a 2. So that is our balanced equation. My dear students, that is where our lesson ended last week. So the catchy statement is metals burn in chlorine to form metal chlorides. And we can write the equation. Therefore, allow us enter into today's lesson. And inshallah, we should be pushed to complete. So that next time we look at properties. We look at hydrogen chloride and continue with properties. We have agreed that we are going to look at 2 reactions. Reaction number 1, we said shall look at displacement reactions. And number 2, we said shall look at reaction with non-metals. What is displacement? Have you ever been displaced? What does it mean to be displaced? Have you ever displaced? What does it mean to displace? If you displace me, what does it mean? You take up my position as I go away. All right? And this happens outside the classroom, at home, everywhere in every community. There is a displacement reaction. What was originally your seat now becomes mine. Therefore, what shall we say? I will have displaced you, and you will have been displaced. So we expect displacement. But for displacement to take place, people must be of the same category. Take up, for example, if I have a senior 1, I have a senior 2, I have a senior 3, and I have a senior 4. Let us imagine as ladies and gentlemen. You enter the library and you find a senior 4 student is seated already in the library. And the rules say elders in the Kibuli are supposed to be respected. Supposing a senior 1 enters the library and finds a senior 4 seated, elders must be respected. Do you expect a senior 4 to stand up so that a senior 1 can sit? No. If a senior 2 comes, a senior 2 cannot make a senior 4 to stand up. A senior 3 cannot tell a senior 4 to stand up. A senior 4 can begin with a very senior 4. You have sat for some time. Allow me also at least to do what? Sit. You can see. So what would happen if the senior 1 entered the library and a senior 4 came in? The rule in Kibuli is elders must be respected. What will happen? A senior 1 has to stand up, give the seat to senior 4. Why? Senior 4 is an elder. So what is being an elder in chemistry? Being an elder in chemistry will take us what we call the reactivity what? Series. Reactivity series. The one who is more powerful will always displace the one who is less powerful. The one who is more reactive will always displace the one who is less reactive. So senior 4s are more reactive. So they displace senior 1s. They can displace senior 2. They can displace senior what? Senior 3s. I'm addressing you as senior 4s because you're already senior 4s. However, a senior 2 cannot displace a senior 4. Even if a senior 4 is very powerful, when an A-level student comes, the senior 4 must give way because the senior 5 and the senior 6 is an elder. Is high in the reactivity what? Series, therefore it's more reactive. When you capture that one, you can handle this displacement reaction. To go back to the gist of the matter, using this preamble, chlorine is a group 7 element written as like that one at room temperature. So what is below, above chlorine is fluorine. So what is below chlorine? What is below chlorine is called bromine. And what is below bromine is called iodine. These are the group 7 elements. What did we agree in senior 2? We agreed in senior 2 that the most reactive nanometals are found on the extreme what? Left. And which are these ones now? Group 7 elements. So these ones are falling in the category of group 7. And what name do you give the group 7 elements? Halogens. So who is the most powerful halogen? Fluorine. Followed by chlorine. Followed by bromine. Followed by iodine. Now, what are we studying? We are studying chlorine. Do you therefore expect chlorine to displace fluorine? No. Because fluorine is now a senior 4. Chlorine is a senior 3. This is a senior 2. This is senior 1. So you can't expect this one to displace. So what will be the reason? Because fluorine is more reactive, therefore cannot be displaced by chlorine. So these displacement reactions come in a combination with other elements, which means I can get fluorine to react with, say, potassium. So what will I form? I form potassium what? Fluoride. Isn't it? So what will happen if a solution of potassium fluoride, I decide to pass chlorine through it, which is a gas? They say, what will happen? Fluorine is married to potassium. Displacement. Chlorine will displace fluorine. Is this reaction going to be possible? No. Why is it not going to be possible? Because chlorine is less reactive than fluorine. So when they ask, what do you see? There is no observable change. Meaning there is no what? Reaction. Why don't we have a reaction? We don't have a reaction between these two because chlorine is less reactive than fluorine. So the bond between potassium and fluorine is so strong that chlorine cannot break it. So there is no reaction, isn't it? Supposing I have KCl and I want to pass chlorine through it. Do you expect displacement? No. The same family, same strength. Senior 4 versus senior 4. Senior 3 versus senior 3. Do you expect displacement? No. So here, what do we expect again? No reaction. What is the reason now? The reason is different. What's the reason? Chlorine is the same element. They have the same reactivity, same strength. You can displace. This is a tug of war. You pull as I pull. So when we are pulling, and you're also pulling out the same energy, nothing happens. So this is clear. May I now task ourselves to look at the next option. So the next option is auxiliary these two. I want to try this one now. Supposing we bring in potassium bromide and we say, let us now bubble chlorine through it. This is a solution. Bubbling means we are passing through a solution. So let us first of all think of the equation. Think of the equation. Displacement. Potassium belongs to bromine, isn't it? In this category. Chlorine also comes in. But chlorine is more reactive, displaces. So what happens? In the position of bromine, chlorine will sit there. So what is the formula of the product here? KCl. And it will be in the solution. So who has been thrown out? Bromine has been thrown out. And once thrown out, two atoms will come together to form one molecule. So we shall have now Br2. Now in chemistry, bromine can be in the form of a solution or can be in the form of a liquid. It can be in the form of a solution or can be in the form of a liquid. Before we go into solution or liquid state kind of thing, let's try to balance the equation. Odd number 1. Odd number 1. So K is equal to 1. What do we see? Br is also 1. But Cl is equal to 2 here. We cross this way. K is equal to 1. Cl is equal to 1. Br is equal to 2. What do you notice? Br this way is 2, which is even. Br this way is 1, which is odd. So what do? We make this odd number also even. So how do we make it even? By multiplying by 2. So I'm putting a 2 here. So when I put a 2 there, what happens? K has also turned from being now odd to even. And this way it is still what? Odd. So what do? We also multiply this by 2. It becomes a balanced equation for the reaction. Dear students, my dear friends, ladies and gentlemen, we expect you to know the color of bromine solution and bromine as a liquid. The following is supposed to be noted. If you have bromine written like this and is aqueous, its color is reddish brown. If bromine is written like this, it means a liquid. There is no water in it. Its color is red. A very dangerous red liquid. Very toxic, very poisonous red liquid. You have covered organic chemistry, so you know the color of bromine and bromine water. So you first of all form bromine water, then from bromine water it goes to bromine, depending on how long the reaction is going to take place. In a very short period of time, you form bromine water. For a longer period of time, you form bromine liquid, and bromine is insoluble in water. So if you have bromine as aqueous, what do you see? A red-brown solution. If you have bromine as a liquid, you have a red liquid, in most cases at the bottom of the container, and so on. So the two physical states acceptable are aqueous and liquid, depending on time. Which one comes first? The brown one comes first. Then when it becomes too much, it turns into red because bromine is insoluble in water. So, which observations can you make now? Potassium bromide is colorless. This is supposed to remain colorless, but because of this mixed with it, it becomes reddish brown. For a longer time, red liquid. So in most cases, you ask what is observed when chlorine is bubbled through a solution of potassium bromide. So what is our observation? The colorless solution turns reddish brown, and after some time turns into a red liquid. Explain. What's the explanation? Chlorine is more reactive. Therefore, this places bromine. Are we there? So bromine in solution is reddish brown, but if it's a liquid, it is a red liquid. So that is what we're supposed to look at as a displacement reaction. With A level, you can do real practicals on this one. Practically in the lab, qualitative analysis. Why can't we subject O level to qualitative practical analysis of this? Because of mention of bromine, which is a toxic what? Gas. That turns into senior one. Did you look at diffusion? Yes. Wasn't this as one of the reagents used to discuss diffusion in liquids? A drop of red bromine was put on a tile and covered with a jar. What did you see? The whole jar was covered with a reddish brown gas, demonstrating diffusion, particulate nature of matter in solids. So this is one of the reaction. Reason, more reactive displaces. If you have handled that one, then you can talk about this one. What is that one? Potassium iodide, aqueous. Now you are passing chlorine through it, a gas. What do you expect? Potassium chloride, which is also aqueous plus iodine. Iodine behaves like the other one. If a small amount of iodine is liberated, we get aqueous iodine. For a very long period of time, not even in about 2 minutes or so, it turns into a solid. And iodine in solution is brown. If it's a solid, it is black. So, senior one, sublimation. We looked at iodine, and these were black crystals. When you hit them, they turn into a purple vapor. But once dissolved in solution, it gives a brown liquid. So why? Chlorine is more reactive than iodine. Therefore, it displaces iodine, which is seen as a brown solution, and after some time deposits a black solid. Why should a black solid be deposited? Because bromine is insoluble in water. So these are the two displacement reactions. Out of these two reactions, which one do you think is more faster than the other? Which one is more faster? The displacement with the iodine is more faster than the displacement with bromine. Because remember, chlorine is next to bromine, but very far from chlorine. I mean from iodine, isn't it? Yes. That's why at home, there is always a problem between the person you follow as children, always fighting, pulling ropes here and there. But between other people, in between the firstborn and the thirdborn, there is no. But first and the second, third and the second, because they are too close, with a difference of about 2 years, there is always competition and so on. When this one speaks, the other one answers back. You can't displace little. But between the two extremes, there is a lot of respect. So, chlorine is far from iodine. It displaces Ki, iodine, than displacing what? Bromine. So, displacement reactions are only two. What have we said? Reaction with potassium, bromine, or reaction with potassium, iodide. Bromine is displaced, seen as a reddish brown solution, and for a long time, a red liquid. Reddish brown solution is formed, which is iodine, and later on black solid crystals are deposited because iodine is insoluble in water. So you can write ionic equations. Let me use this one to write an ionic equation. Then alone, you'll write the ionic equation between chlorine and potassium iodide. So potassium bromide ionizes to give us potassium ions, aqueous, plus this one will give us bromide ions, aqueous. From a balanced equation, I've seen there is a 2. These 2 controls everything. So this means a 2, and this one means also a 2. Plus, chlorine has no ions in it. It is a gas. What are we obtaining? 2 molecules of potassium chloride. From potassium chloride, we are getting 2 ions of potassium aqueous plus 2 ions of chloride ions, also aqueous. Bromine aqueous doesn't have ions. Or in liquid state doesn't what? Ionize. So it is Br2. Let's take this first to appear aqueous. So what did we agree the other time? Spectator ions, we remove them. Whatever is found this way and that way, we shall remove. So you have seen the potassium this way, potassium that way. Hatoti come, hatoti go. We have seen bromide ions, there are no bromide ions the other side. Do you see bromide ions the other side? No. Do you see chlorine the other side? No. So these will remain. So what is our ionic equation? Our ionic equation is bromide ions, aqueous. Should you add chlorine to them, which is a gas, you end up forming 2 chloride ions, aqueous, plus bromine, which is either aqueous or what? Or liquid. It's the ionic equation. So we don't displace bromide ions. We displace bromine. When you are displaced, you go as bromine. You don't go as bromide ions. So this is briefly what we can share about the displacement reactions. Take note of these 2, commonly used in O-level examinations, especially at that last level of evaluation as you plan to change uniform and go to A-level. So as I promised, that one is complete. Next, we looked at reaction with non. We're going to look at reaction with non-what? Metals. And the game is over. What are these non-metals? There are few non-metals we can look at. These include, if you can figure out a reaction with sulfur, you can figure out a reaction with phosphorus. You can figure out a reaction with carbon. Oxygen, most likely I'll try it out. Nitrogen, not so much. At least these three non-metals. Of course, hydrogen can also come as a non-what? Metal. And also comes in as a metal. This one, we looked at it. So if you can figure out this, it is possible. So, chlorine and sulfur. So what you do? Sulfur chloride. Good trial, sulfur chloride. But the formula of the chloride we get is that one. So it is called disulfur, meaning there are two sulfurs. Disulfur chloride. Sulfur has many valences, ranging from 2 to 3 to 6 to 4 and so on. So we shall take that one, sulfur disulfur chloride. Phosphorus will give you two products. The first product will be phosphorus tri, and the second will be phosphorus penta. From your O level, phosphorus has two valences, a trichloride and a pentachloride. And without going into the details, carbon gives us a compound that we call, at the end of it all, carbon tetra. Tetra means 4. So this is disulfur chloride. This is phosphorus trichloride. Why are we saying trichloride? Chlorines are 3. You can call this disulfur dichloride if you want. Why is it disulfur dichloride? 2 sulfurs and 2 chlorine. So what about this one? Is going to be phosphorus pentachloride. This one is carbon tetrachloride. So 1 carbon and 4 chlorines, tetrachlorides. All of these reactions involve giving out of heat and a flame. Right? So phosphorus binds in chlorine to form phosphorus trichloride and phosphorus pentachloride. Carbon binds in chlorine to form carbon tetrachloride. Sulfur burns in chlorine. Burning sulfur lowered in chlorine continuously burn and you end up with disulfur dichloride. So your biggest challenge here could be just knowing the equations for the reaction. But the most important reactions: displacement, reaction with metals, reaction with chlorine with water, reaction of chlorine with the sodium hydroxide. Noting this one is not bad, but those other ones, very important. Displacement, metals, sodium hydroxide, water, and maybe hydrogen. Very crucial. So it means that here we can figure out the equation for reaction. I want you to take off about 30 seconds and see if you can write the equation for reaction and balance it between sulfur and chlorine without checking. Write a balanced equation for reaction between sulfur and chlorine. So I'll write the unbalanced. Sulfur is a solid, chlorine is a gas. So what do we form? We are going to form S2Cl2. So balancing the equation, 30 seconds. When we finish that one, you also balance your equation with the phosphorus. Phosphorus is written as P4 and is a solid, plus chlorine, which is a gas. These are the white fumes PCl3, which is gas. Balancing that one. Let us also as individuals attempt to balance P4 solid plus chlorine as a gas. What do we obtain? PCl5 as a gas. See if you can balance. However, it could have been just P plus Cl. I'll not refuse. Those who say P plus Cl will give me PCl3 and P plus Cl2 to give me PCl5. If you can't write it like this, take that format. If you can't write it like this, take this format. But what you want is a balanced equation. So 30 seconds, 30 seconds, 30 seconds, 1 minute, and 30 seconds. And the last one for 2 minutes is C, carbon, a solid, plus chlorine, a gas. We get CCl4. CCl4 is a liquid. So 2 minutes in balancing those 4 equations quickly, and we continue. One minute is over. You must be thinking of the second minute. This one is from. Which one is finished? Diffusion. But the result is So I have seen samples of answers. Check. We shall balance now together. There is chlorine, sulfur is 1, here sulfur is 2. Chlorine is 2, chlorine is 2. What is our usual song? Make the odd number what? Even. So how do we make it even? By multiplying 1 by 2. So this should have been your balanced equation. If you have that as your balanced equation, mark yourself. Now let's come to this one. P4 Cl3. This is even. This one is odd. Let's make this even number, odd number here also even like this one. What does it mean? We shall put a 4 here. When you put a 4 there, chlorine will change to 12. And if this is a 2, which number should we multiply by 2 to get 12? Is a 6. If you use this format, using this format, what do you see? Phosphorus is odd, phosphorus is odd. Here chlorine is even, here chlorine is odd. So we shall play about with chlorine. But now, if we put a 2 here, chlorine will be 4. Writing 4 this way becomes difficult. So the best you can try is a 3. So that they become how many? 6. And if that becomes 6, what we do? We multiply this one by 2 and also put a 2 here. So it is either this format or this format. Of course, here we have already seen this is now a 4 because of phosphorus. Chlorines are how many? 20. These are how many? 2. Which number should multiply by 2 to get a 20 is a 10. If you had used this format, what has happened? I think you have seen putting a 2 here gives us 10. This is a 5 and that is a 2. And lastly, the one for carbon. This one is very cheap for us to handle. 1 carbon, 1 carbon. 2 oxychlorines, 4 chlorines. So what do we do? Multiply chlorine by 2 and it becomes a balanced equation. So you mark yourself and give yourself so many marks out of 4. If you have 4 out of 4, well and good. If you have less than that, we shall continue learning to balance equations. Allow me at this moment in time go into uses of chlorine. For any student who has attended a lesson on polymers, but that is fine. Let me make it obvious. Any student who attended the first lesson should tell us at least one use of chlorine. At least one use of chlorine. At least one or two. At least one or two. So, beyond, people know quite very many, not only one. Number one, remember, chlorine is used to bleach. So, it's a bleaching. Itself is a bleaching agent. Where exactly? It can be used in paper and textiles and the paper industries. Itself as chlorine. But remember, it can also be used to manufacture bleaching agents. Manufacture of bleaching agents. Things are funny. You do the work, even your children do the same. Yeah? So, what are these bleaching agents? Things like what? Jik, things like Vim, things like Harpic. All of them have chlorine in them. So it bleaches. And its compounds also what? Bleach. Remember, we talked about water what? Treatment. Water treatment. Which process is that? The process is called chlorination of water. How many things are done? Two things. Number one, kill germs. Number two, remove bad color and smell in water. Courtesy, chlorine in water. Any other? There is what we call for organic chemistry PVC. What is PVC? Polyvinyl chloride. A polymer whose formula is CH2CHCl, and the polymerization will continue. Common name, chemical name, polyvinyl chloride. Chemical name, chloroethene. Commercial name. This could be more of the plastics or PVC pipes, the common water pipes that we are using. Even here, PVC pipes available all through and so on. So water pipes, sewage pipes, and so many. All those derivatives of polymers, polymer-like, and so on. Insulation of electrical wires, PVC, chlorine, not anything else. Any other use of chlorine is going to be used in the manufacture of salts. Other things like hydrochloric acid. You can't get hydrochloric acid without chlorine, and it's an important acid. So there are so many uses of chlorine. Out of the so many uses of chlorine, you master about 3, because the question calls for 1 or 2 uses. There are quite very many uses of chlorine. Manufacture of other salts, other compounds like chloride, so reaction with metals, hydrochloric acid. Now here you have seen it's a bleaching agent and also bleaching agent for water treatment, manufacture of plastic pipes, and so on. When you read, you come across other uses of chlorine. So also do some reading and capture some other uses of chlorine. Add on to the list that has been provided by the teacher. All right. So I want to say this morning we put aside chlorine. Now we shall look at the compounds of chlorine. Let's go into compounds of chlorine. We shall look at one major compound of chlorine. That compound of chlorine is what is called hydrogen chloride gas. That will take us something else. Hydrogen chloride gas. Therefore, the syllabus requires that each one of you knows how to prepare hydrogen chloride gas. So, preparation of hydrogen chloride gas. You can write the essay, figure out what's supposed to be done, as long as you handle the following. The gas is hydrogen chloride, written as HCl. Preparation. What are our reagents from which you can prepare hydrogen chloride gas? Our reagents include common salts, which is sodium chloride. You can also use potassium chloride. You can think of another chloride other than the sodium chloride. I can give you magnesium what? Chloride. As long as it is a chloride and the reaction can take place. Other than this, we shall require sulfuric acid. So I am saying a metal chloride, and sulfuric what? Acid. The question is, will all metal chlorides react with sulfuric acid? No. So, metal chloride, any metal chloride, except kumbaga takubula ko basiyufu. What are the basiyufus will not give us hydrogen chloride? They are 3 of them, and you must tell me why. Number 1, I cannot use lead 2 chloride. I cannot use barium chloride. Neither can we use calcium chloride. Why? Think about it. Why? Why can't we use those chlorides? Those are the only chloride that will never give us hydrogen chloride gas. The rest will give us. But commonly used is sodium chloride. Why? Go back to senior 2, salt chemistry. What do you know about these salts? This salt is insoluble. This salt is soluble. This salt is soluble. Sulfuric acid does not donate a sulfate ion. Sulfuric acid donates a sulfate ion. The metal chloride donates a metal. So, what do you expect if you use sulfuric acid? If you use sulfuric acid, what will you obtain here? Barium sulfate. Pardon? It will be lead chloride. If we use lead chloride and sulfuric acid, what will happen? We shall end up with lead what? Sulfate. This one will end up giving us barium what? Sulfate. This one will end up giving us calcium sulfate. What do you know about the 3 sulfates? Those 3 sulfates are insoluble, and therefore the reaction cannot take place. So why don't we prepare hydrogen chloride gas from lead 2 chloride, barium chloride, and calcium chloride? Those 3 are not used because they form an insoluble, a protective layer of barium sulfate, lead 2 sulfate, calcium sulfate, that stops the reaction from further taking place. So you need to remember senior 2 chemistry, and this one is insoluble. Otherwise, it could have been possible. So if I got, for example, lead 2 chloride, and I added sulfuric acid to it, this lead 2 chloride is going to react on the surface to form PbSO4, which is a solid, and give some 1-2 bubbles of a gas, and it will stop. Because inside we shall have lead 2 chloride, but the outside will be coated with a film of lead 2 what? Sulfate, and therefore it stops the reaction from further taking place. So that is it. So we shall not use that one. So let us go to the second requirement. Conditions for the reaction. If you don't fulfill this condition, the reaction does not take place. You fulfill, the reaction takes place. Then you keep telling us when time for going to school comes, that without buying 20 liters of Jolly Jazz Super Deep, I want to go to school. So I don't provide 20 liters, you don't go to school. It's a condition. All right? So that's what I say. You keep quiet, stop crying, then I'll give you. If you are crying, I'm not going to give you tea. Stop crying first. So what happens? The child stops to cry, you give tea. So without stopping to cry, no tea. So there is a condition. For this reaction to take place, ladies and gentlemen, the acid must be concentrated. So we need concentrated acid. If the acid is dilute, no reaction will take place. You may not require to heat, so the reaction will take place at room temperature. I.e., heating is not what? Is not required. In our usual style, hydrogen chloride is a very soluble gas. You can't attempt to purify it. You'll get nothing. So what do? We start away head for drying. What should be our drying agent? What should be the drying agent? Concentrated. Our drying agent should be concentrated sulfuric acid. And as usual, we must discuss why do we use concentrated sulfuric acid. Why do we use concentrated sulfuric acid? The gas is acidic. This gas is acidic in nature. And sulfuric acid is an acid from its name. We can't expect these two to react. So why do you use sulfuric acid? Sulfuric acid not react with the gas because the gas is also acidic. Take note of that. It is the same thing I've been telling in relationships. It's the same thing in relationships. You can't expect a sister to marry, or a brother to marry his own sister, to marry her own brother. It is not possible. Abomination. Culture does not allow people of the same blood. You can't marry your own relatives. You are people of the same lineage, same pedigree, same origin. So all of them have the same origin, acid. You can't expect marriage reaction to take place. However, with a foreigner, marriage is allowed because these people have different origins. I am not your blood relatives, therefore marriage can take place. So we cannot dry a gas which is acidic, we dry with an alkaline drying agent. It is not possible. Or we dry an alkaline gas with an acidic drying agent. Why don't we dry ammonia using sulfuric acid? Ammonia is basic, sulfuric acid is an acid, the two will react. So this is the scenario that we are having here. So method of collection. So method of collection. A method of collection is downward delivery. And again, we have reasons to ask ourselves, why do you choose downward delivery? These are scenarios. And I'm telling people, jokingly in the class, you think it's time for making fun, but for real serious lessons. Somebody tells you, I love you. Why? Without reasons, genuine reasons. So even chemists of that nature, each time you are giving an activity, give the reason. Why have you chosen this method over others? Why me over others? Let the person justify himself in the future. So the unique selling point to come out. The unique selling point is that this gas is heavy. And because it's heavy, you can collect it downwards because you want to displace air. So it is heavier than air. Displacement can now take place. So my dear students, what type of gas is this? From our usual discussion, it is a GDC gas. What is a GDC gas? A GDC gas is a gas where you generate. Where is generation? Generation is here from those. After generation, what do you go to? Drying. And therefore the drying process is here. This one will give us generation. The reagents and the conditions to generate. Therefore, this is the drying level. This is the collecting level. So how many sets of apparatus do we have? There are 3 sets of apparatus. Generation apparatus, drying apparatus, collection apparatus. Which thing should have stopped? We should have given only and only senior 2 and we stop. By this time, you should be in position to draw your diagram and explain, write the essay. So for purposes of harmonizing each and everybody, let us think of the simplest diagram. And from the diagram, I will summarize the lesson. So, generation step. Remember rules governing apparatus that we gave you. The choice of the apparatus will determine the type of diagram to draw. Therefore, what did we agree? The moment you use a flat-bottomed flask, flat-bottomed, how shall we know it's flat-bottomed? By seeing that. It means it can support itself on the table. The moment you bring in a round one, you must hold it. Clamping is necessary. So this I'm not going to clamp. So what else is accompanying generation? Sulfuric acid physical state is in liquid form. Sodium chloride, solid state. So I need to pack the solid here. But I need something to bring in the acid up to the bottom. So this one will give us generation. How do I come out? I'm now connecting the drying step. This one will bring us the drying level. If I left all doors open, I stood outside and said, you students, you come and I came. Will you come? You pass through open places. So make sure for you to come out so that you are punished, you close all the avenues where you can escape from. So let us close off this container so that the gas doesn't escape. It is a punishment to pass through the acid. So why do you punish yourself struggling to go through the acid yet you can easily escape? Drying tower. Don't struggle drawing a very complicated wash bottle. This one can work. And therefore another delivery tube comes out. We are heading for collection tower. To avoid the gas from escaping, I am closing it off. Look at the incoming tube. It's longer. Now, we say the sulfuric acid. The incoming tube must go below sulfuric acid. Collection. You told me which method? Downward delivery. You can see the gas is coming out. Downwards. So there must be a gas jar here. Now, we talk about displacement. Meaning that before the reaction can take place, there is air here. How does the air go out? This diagram becomes a wrong diagram. Though this is what you have in the textbooks, because downward delivery means upward displacement of air. Where is air going to escape from? So there is what we call WA, working apparatus. You missed that one mark. So WA, 0. Wow, it's not a good diagram, it's a bad diagram because it has errors. I don't want delivery tubes that are sharp. I've said I want the curved ones. These ones, I don't want them. So I want the curved ones. So let me clear the way for the air to get lost. As the gas is coming to goes down, the air is going to what? Escape. There must be an acid level to show the acid level. So there is now this one inside. This tube comes below the surface. Rules governing labeling diagrams. We agree. Don't use abbreviation, don't use symbols. So I expect my students to label this. I expect to label this one. I want you to label this. Don't use abbreviations. So what is this? Concentrated sulfuric acid, not conc, because you are in hurry. Conc sulfuric acid, the word conc doesn't exist. Let us not use any SCl. Let's write sodium chloride and so on. This is our diagram of apparatus that you have labeled. So we are ending by looking at procedure. The essay. I have given this essay and I want to repeat for purpose of those who have forgotten, maybe for those who are sharing screens with neighbors who are not our students. The essay. The activity must have a reason. So what do? What shall we put in the flask? What do we begin with? We begin with the flask reagent. So what is going to be put in the flask? Sodium chloride is put in the flask because it is a solid. Step number 2. Concentrated sulfuric acid poured down into the flask through the piston funnel because it is a liquid. The reaction takes place at room temperature. The gas is passed through concentrated sulfuric acid to dried because it does not react with the acid since it is also acidic. The gas is collected by downward delivery because it is heavier than air or denser than air. And lastly, our equation for the reaction. Let me now write the equation for the reaction. So the equation for the reaction is sodium chloride is a solid in the flask plus concentrated sulfuric acid in the piston funnel because it is a liquid. What do we obtain? We already know one product. So one product you already know is hydrogen chloride, which is a gas. What's the other? You check. Sodium sulfate. You could have gotten sodium sulfate, but the major product is sodium hydrogen sulfate. At room temperature, this is the major product. However, at a higher temperature, that's when you can form sodium what? Sulfate. So are we heating? No. Do you wait for something that is very far? No. We go for the immediate. So don't think of sodium sulfate. Think of sodium hydrogen sulfate. And the work becomes complete. So I want to ask that in the remaining period of time, if you have not drawn the diagram, I said the notes, you don't need to draw. Just go back to the notes and read it through and see what happens. So what does it mean? We have already captured an acidic gas. We are now left with properties of hydrogen chloride gas. If there are issues, you send them on the web, on WhatsApp group, and shall be interested to look at them. I want to thank you.
There is a question.
There is a question.
There's a question here.
Just a moment. Don't sign out as yet.
There's a question here. So, is there another acid which we can use?
Is there another acid you can use to prepare hydrogen chloride gas from? No.
As a reagent, apart
It,
from sulfuric acid.
it is strictly sulfuric acid as the only reagent you can prepare hydrogen chloride gas from. However, the other ones can be many: sodium chloride, calcium chloride, not good, magnesium, copper chloride, zinc chloride, all those ones are possible. The acid is only and only one, which is sulfuric acid. Thank you for that question. There is no other acid other than sulfuric acid, ladies and gentlemen. So I think I'll stop here as for now. Read ahead so that you can capture properties of sodium hydrogen chloride and hydrochloric what? acid. Assalamu alaikum wa rahmatullahi wa barakatuh.